Thank you. Looks like day two, we have a little less, or maybe people are, enjoying the nights too much. That's always a good thing. Thank you for having me. I think we have covered a lot of different topics since, I would say, since Tuesday. If you look at the theme, I think we talked about 5G end-to-end. We talked about automation. We talked about different topics. So this one is a little deeper. I would say a bit more of a double click on IP networking, the favorite topic, right? The most critical, most important topic on the planet across everything we do, right? So we'll go into that, and feel free to ask questions. Since we have a smaller crowd, we can afford a few extra questions. Is that okay? All right. Thank you. All right. So I know, wait, this should be on. It is on. Okay, there it is. All right, so, I think you've heard this throughout the week from us, which is essentially what we see globally in terms of bandwidth growth, right? And 50 to 60% anecdotally, the growth rate of traffic in various service provider networks, 31% as predicted by Cisco VNI, with busy hour being even more. But the other angle inside of that is video is a large component of that. So 82% of traffic in the network expected to be video in 2022. But that other 18% cannot be ignored, right? So that's critical. So we are going to keep that in mind. Second piece is 5G. Yes, it's difficult for people to identify all the killer applications today. But the reality is when you have an order of magnitude change in any critical performance indicator, right? So when you have an order of magnitude change in bandwidth, an order of magnitude change in latency, you can be guaranteed that that will serve as a platform for innovation. So new use cases, new applications will come up. They're probably already being cooked, and that will happen. All right, so that's the exciting part of our journey. And clearly from a Cisco perspective, we do look at web scale and cloud as a critical area, both as a tailwind as well as something that affects all of us in terms of business model and economics. So clearly these factors, the growth in bandwidth, the mix of traffic, the changes that are coming up with 5G, and the economics and the business model changes that are driven by web are big factors in how we build networking. So when we say networking, I would say routing and switching. Today I'll focus a lot on routing, but these factors really influence how we build routing. With me so far? All right. Okay. So let's go now double click further. I think this is slow. All right. All right. So as I said, today's session is going to be a little deeper. So we'll jump right in. Yeah, maybe the battery inside. Yeah. All right. So when we look at the routing innovation, we are obviously focused on economics. There is no question, right? Every one of my customers is focused on cost transformation. So clearly, if we are going to be successful, we need to be focused on what our customers are focused on. So cost transformation is critical. And that is something that is enabled by silicon and optics. Those two are important factors in the cost of networking. And the reason, I don't think I have to share this with the SP community, clearly if bandwidth is rising at that rate, CapEx is flat, right, capital spend, then Cisco or anyone who's providing you with networking cannot say, hey, you need 4 times the bandwidth, just spend 4 times the capital. You cannot, right? So we have to innovate in these spaces so that we can reduce our cost per bit so that you can reduce your cost per bit, and at the end of the day, the whole system remains healthy. So in terms of silicon, our philosophy is clear. It's around silicon diversity, so I'll talk about that. Optics, we'll talk about that. Once you've taken silicon and you've taken optics, you've built hardware around it. We look at the network OS, the operating system that runs on these routing systems, right? For us, that is iOS XR. So what are we doing there in terms of the capabilities? Then once you have built the router, you have to build the network because it's about the network. So what are the end-to-end network architectures? And clearly, once you have built the end-to-end network, how do you operate it? How do you even bring it up the first time? It has to be fully automated because the other part of the cost equation is OpEx, right? And it's not just about cost there, it's also about service velocity, it's about the experience of your customers, fair? So these are essentially our building blocks that we will cover. And as I said, today is a little double click. So, I hope we all stay together in this conversation and in this discussion. All right, okay. The battery works, which is great, thank you. So let's go one by one. Silicon innovation. If bandwidth is rising at that 50, 60% year over year, or even 30% year over year, we cannot be doing silicon every 3 to 5 years because that's going to be slow, right? So one of the things that we have focused on in Cisco is under the uniform operating paradigm of iOS XR, how do we give massive silicon velocity? Both from a business model perspective and also from a technology perspective. Clearly, technology comes first, but it has to be married to a business model. And I'll talk about both those angles today. So from a technology perspective, what we have done is under that operating paradigm of network OS, single network OS, same CLI, same API, same telemetry, same way of doing networking, we have multiple options. We have merchant silicon, as in Broadcom DNX or Jericho, everybody knows that. So we have that family. We have Cisco silicon, like in the ASR 9000, right? And the idea is that we should be able to deliver a revision to silicon to density every 12 to 15 months. That's the velocity we will be operating it at. And that's important. That is super important. So silicon is a big area of innovation for us. And reason we do both is because the world needs silicon diversity. And everybody, whether it's a startup ecosystem or the large players, everybody's focused on data center switching and top of rack. Why? Because that has massive volumes. Very few people are actually focused on routing. And Cisco is focused on routing and switching both. Why? Because we believe that the world needs to remain relevant and competitive in terms of silicon for routing, right? So that's a big investment for us. Of course, we are fully bet on Jericho as well. So we do both. And Jericho, Jericho Plus, Jericho 2, we have been shipping them as they come. And Cisco 1, Cisco 2, Cisco 3, we have multiple. We have multiple Cisco families of silicon. We're focused on that. Fair? Again, just connect that back to the goal, which is if we don't innovate in silicon fast enough, we will not be able to keep up with bandwidth, or the cost will rise beyond your ability to make revenue. So big area. And 400 gig is big. This year, literally across everything we do, we will have 400 gig. We are obviously marrying that to optics, which is the next topic. All right. So if you look at the cost per bit of moving traffic, from Andrew Vaz there to John O'Hare here, you cannot ignore optics. I'm just kidding, by the way. We move traffic between cities, but actually through people. It emanates from people. But the point is, it is critical to not miss the optics economics in the equation. And they are becoming increasingly more critical. Is that fair? Right? The cost of optics is very, very critical. So at Cisco, we have a history of enabling optics innovation. So when 100 gig first came out in the industry in routing, we built it on CRS. It was a platform we called the CRS3. I still remember launching it March 2009 or 10, maybe 10, sorry, March 2010. And we didn't have the right optics available in the industry for 100 gig at that time. So we had to build something called the CPAC, to support 100 gig transition. Why? Because the economics required a transition to 100 gig, and to move the industry forward, we had to build our own at that time. And then, of course, later on, lots of different choices became available. We're doing the same with 400 gig. We have invested in many startups to move the technology forward in terms of 400 gig optics. So in the back of what you will see is a lot of help from Cisco. Sometimes it's behind the curtains, right? And of course, we have also acquired Luxtera, which has immense capabilities in optics as well as in co-packaging. And this is all public information that you can read about. Again, the goal is to move the economics forward for the whole industry as far as optics is concerned. All right? So now we took silicon. We have the diversity. We have the velocity in silicon. We took optics. Now we built the hardware. All right? We built the hardware so far. Now we are going to put an operating system on top of it. All right? So when we put the operating system, when we combine hardware and software, we call it systems, right? So obviously, systems means now it's like your favorite routers, the best routers in the world, like the ASR 9000s or the NCS 5500s or the CRS, whichever one you love and like from Cisco. They are all, we call them as systems, right? We brought hardware and software together. And clearly, we have, the approach we have taken is that you should be able to consume or deliver bandwidth in the form factor you need. So if you need, if you go back 15 years ago, we used to have iOS XR on what was called CRS, the carrier routing system. And it was big, right? Really heavy, big. We loved it. It was beautiful, right? But today, we can take the same OS and ship it on platforms that are literally 120 gigs of bandwidth to platforms that are 58 terabits, 64 terabits today, but soon will be many orders of magnitude higher. So the ability to consume and deliver bandwidth with the same operating paradigm, all the way from access to pre-aggregation to aggregation, core, edge, peering, same operating paradigm, but different form factors. Make sense? And then use the right silicon in the right location, because in some locations you need a lot of scale and state, but maybe the bandwidth can be a little less. In some locations you need lots of bandwidth, but less scale, less state. We have the right silicon so that we can drive the right cost point for the right part of the network. So that is the innovation in systems. That's how we build hardware, right? And that results in obviously some capabilities. Now, on these systems runs our operating system, right? The iOS XR. I think a few things that I want to share about the innovation in the OS. This is something you have to care about. So if the strategic goal is that network is a platform for innovative new services, then the software that runs in the network across all these routers is kind of like the platform. Okay, visualize that as your platform. And on top of this software is all the stuff you need for programmability and automation, right? And this needs to be super automatable, whether it's zero-touch provisioning, whether it is the ability to drive APIs, whether it's the ability to get information from the network, a lot of data from the network, insights from the network, current bandwidth conditions, all that stuff. You should be able to get that easily from the network, from this entire network. So we have clearly enabled that. We've also enabled all that in an open fashion. What I mean by that is every one of our APIs is actually on GitHub for anyone. So we're not hiding something. It's open. Anyone can program around it, right? And we have embraced open config. We have at least in our analysis, we have the most wide support for open config than anybody else. All right? So super programmable, right? And super flexible. So even things like access to our RIB in the form of APIs is available for super advanced people who want to do super advanced things. So you have a very open system, all right? So that's a big thing. Now, the other piece that I want to talk about is telemetry. I would say in the last quarter of 2018, calendar quarter of 2018, was the first time one of our customers, actually with iOS XR, removed SNMP from their operating paradigm for their network. First time. We talked about this 3-4 years ago. It takes time to do it, but they are totally running the network on telemetry. So initially, they were running the network on SNMP and CLI, and telemetry was like a validation. You know, they were double checking things. Now they're running the network on telemetry, right? They're running their automation system on telemetry. So that's beginning to happen, and clearly, you know, that's because you get a lot more volume, velocity, and variety of data from the network, right? For all the action we talk about in terms of learning, machine learning, all that stuff, it has to be powered by data from the network. And that data, we make it available in spades. And sometimes you have to make it available only when it's needed, because if you make it available in spades all the time, your costs on the other side will go up, right? Because consuming data, processing data, storing data requires us to spend money. So how do you do it efficiently is important. And the third angle on iOS XR that I want to highlight to you all is our innovation in simplified forwarding and simplified services. Because we are not building network because we like to build routers. We are building networks so that you can run network services on it, and network services is what makes money, right? You have to make money out of the network. So how do you run those services? So in the past, we had VPLS had its own stack. MPLS obviously had its own stack. L2 VPN had its own ways. Layer 3 VPN had its own ways. Internet had its own way. Everything had its own way because they all kind of got developed in their silos as the needs arose and different people were involved. So what we have done now is we have, you know, in terms of all the greenfield networks that you see today, if you look at any new network we build, and even existing network, as we migrate brownfield networks to a new paradigm, we're saying, okay, let's standardize on segment routing as the underlay, one way, and let's standardize on EVPN as the signaling. And so what we have done in iOS XR is aggressively ensured that any network service, revenue generating network service you do can be operationalized with pure SR and EVPN. So that's the journey we have been on. And that is good in another way, which is, so it simplifies, because when you standardize something, it simplifies, right? It also makes it easier to automate, because imagine automating across many vendors, which I advise you not to go, just go with one vendor. It's always good. But you know, just talking about your equation is, you know, many vendors times many protocols times many, you know, many different ways. It's expensive, it's slow, it's difficult, right? So we are trying to help you with, you know, we'll give you the best test. I know that's not the right word, but that's okay. We'll give you the best test systems and then a uniform way of doing it, right? So you can automate on top, because at the end of the day, it's your business outcome that matters, right? Everything else is, you know, religious. Yeah, it's good, but it's the business outcome that matters. Fair? All right. So the last point I want to make on iOS XR, which is very critical, is you can run it on custom silicon, like Cisco silicon. You can run it on merchant silicon. We have DNX and XGS families supported. You can run it on x86 in a virtualized form factor. And you can run it in the cloud if needed. We actually have an instance in AWS that you can leverage. So it's very flexible. It's available now, and it has a history, a track record of you know, making our helping our customers achieve real outcomes, right? All right. So that's iOS XR. So if you took all the hardware and you took iOS XR, you combine them together, you have obviously a portfolio of systems, right? that go all the way from access to aggregation to edge to core, data center interconnect, peering, everything is covered, right? Now, everything is covered with a uniform, unified operating paradigm. And everything is covered not just for your current revenue generating services, it is covered in a fashion that you can deliver new revenue generating services using our segment routing technology. So this week, we have been talking about 5G a lot, right? And in fact, I'm wearing 5G socks. I'm not kidding. I have socks that have 5G on it. So you know, how many of you heard the word slicing this week? A lot of times, right? How do you think slicing happens? All right. Okay. So the way slicing happens is, you know, if you try to do it in hardware and in very fixed ways, you are not going to set your network up for long-term success. But if slicing was software defined, was driven, you know, in a programmable construct with automation, then you're ready for the next decade. The investment that you will make, the capital investment that you will make in all this equipment will strategically get you ready for the next decade. And that's my number one message that I want to give in the context of 5G. Don't just build your network, oh, I need more capacity, let me just go upgrade these things. No. Build it more strategically as converged infrastructure that will enable mobile broadband, but many, many, many other things that some of which have not showed up yet. But they will show up. Why? Because history tells us that when there is an order of magnitude change in critical performance indicator, it will result in innovation on top. So that is coming. And we'll be all shocked. Oh, wow, we didn't visualize this, right? It'll happen. So the idea is to get you ready for that, and that's what we have done with our segment routing traffic engineering, which can be built at scale, automated at scale, and makes you ready for the next decade, all right? So that you can make revenue whatever shows up, all right? That's the vision. Okay, now we built the systems, right? We started with silicon. We took the optics, we built the hardware around it, we put a OS on top of it. We did segment routing, we did EVPN, right? Those are like the building blocks. So now we have a beautiful router, right? Now we are going to look at the network. We are going to look at the end-to-end picture. So with all the traffic shifts and traffic growth that we are seeing and the revenue potential that we need to drive, at Cisco we believe that there are 4 key architecture transitions that we need to drive together, that we see is going to happen, we need to drive, whichever way you look at it, that are critical, all right? So 4 very critical ones. So I'm going to go through them one by one. And there is a control point, which is automation in everything we do, right? So the 4 transitions have to be supported by automation, fair? So let's talk about the 4 transitions. First is converged infrastructure, right? And some of you may have been with me in one of the kickoffs on Tuesday, and I may have covered it, but for those of you who are not there, let's talk through these. So first is being able to take different types of access, whether you came wireline, whether you came TDM, whether you came through cable, whether you came through a radio like wireless, does not matter. Let's put it all on the same converged IP network, right? That's one thing. Same thing applies to even applications, whether you were an enterprise customer, like a revenue stream, right? Whether you were mobile broadband consumer, whether you were a IoT network, whether you were a bank, doesn't matter. Can we put it through a converged infrastructure, yet give you SLAs as if you had a network to yourself for that application? So that is the promise of segment routing. That's the promise of the architecture, right, that we are driving. But we want SPs to be able to build one infrastructure and serve multiple revenue streams. Fair? So that's one. Second piece is the same thing now with subscribers. Whether you came through a cell phone, which basically means you were on a packet core, or you came through cable, that means you were on DOCSIS, or you came through wireline, which means you were leveraging the BNG control plane. The reality is Mahesh, right? It's the same user, right? So the point is a user is the same person or same thing, but can come into access network services through different means. Is that fair? So one of the directions we are driving towards is take the subscriber control plane and make it cloud native and have the ability to drive unified policy across multiple subscriber technologies, right? Now that's the vision. We'll get there. Initially, obviously, there will be 3 different stacks, but there is enough commonality that we can drive in that direction, right? So control plane goes cloud native. The data plane for these technologies, these subscriber management techniques, can still leverage NPU economics, because NPUs, network processor units, are way more economical than x86. That's the situation today. How much bandwidth you can drive through a virtualized data plane versus what you can drive through an NPU, the economics are very clear at this point. So we will continue to leverage NPU for data plane. We can leverage x86 for data plane where it may make, there might be small cases where it makes economic sense. We'll do that. But control plane can absolutely be cloud native and on x86. So that's the second big shift we are driving. All right. The third one is we built converged infrastructure. We scaled subscribers, and subscribers could be machines, don't forget. So there's a lot of them, more than humans, right? Now all the subscribers are consuming or generating content, fair? Right? And 82% of traffic is going to be video. A lot of bandwidth. Where is that video coming from? Netflix, YouTube, right? Those are the types of places from where you're getting it. So how do we make sure that the bit kilometers, the amount of distance content is traveling from its source to the eyeball is minimized? Because if we minimize that, we can reduce costs. Is that fair? The longer it travels on the network, the more optics and optical and routing it consumes, the more expensive it is, right? So how do you do that? You do that by peering not from 3 locations in a big country, but rather more distributed. Fair? So intelligent distributed peering is another shift that we see occurring in the networks. So we are going to see more and more providers peer from more and more locations. So caching, peering, and subscribers are going to be closer to each other and more distributed. Reduces blast radius, reduces bit kilometers, so it's cost effective. Fair? Something goes down, less users go down. And obviously, we improve the economics, right? So that's the third one we visualize. Fourth one is how do you enable the third one? We do see an evolution of compute moving across in the network. Compute capability not just being restricted to big, large data centers at the center, but getting more distributed. And it's already happening. So initially, there were large centralized data centers, national data centers. Then we see more and more regional data centers already in the telco network. The next one is compute becoming available at the very edge. And in the last 2 to 3 quarters, we are beginning to see a trend in this direction, right? So we call it as service provider data center or MEC, whichever word, phrase that you like, but that refers to this trend. It's happening. It's happening. All right. So these 4 are the big shifts that we see, that we are driving towards, all of them are supported by automation. So there should be no architecture we should describe to you without having an automation story with it. Because that's the only way to build scalable networks. That's the only way we should be operating networks. So automation will be key in everything we say, everything we do. All right? So this was a very big slide, very key slide. Let's talk a little bit about these shifts, a few of them, just a few case studies. So if you look at peering, I talked about peering, and I said peering is going to distribute. So when something distributes, you have to look at what does that mean to the threat envelope, right? You have to look at it from that angle. So obviously, when we look at peering, we say, okay, if this is going to be more distributed, we need to make sure that, in any service provider network, the most amount of DDoS attacks, come from peering points, from peering routers. That's where they come in from, right? That's how people attack SP networks. So clearly, a good peering solution is one where DDoS protection is integrated, right? So like Cisco and Arbor are integrated, or Cisco and Radware are integrated. That's why, because peering locations require that. That's an integrated architecture. And then you have a feedback loop with FlowSpec to make sure you can rapidly cut traffic out right at the router itself, right? So that's second piece. So because the content is a lot and bandwidth is growing, your peering router solution should be capital efficient. So that's one. Second is it should protect against DDoS. That's second. Third piece is, where do people make the most mistakes in routing? Routing configuration, routing policy, at the peering routers. That's where we make the most mistakes. If you look and Google big outages and you study them deeply, 3-hour, 4-hour outage here or there, it'll be a route policy mistake, a routing loop or something like that, somebody attracting routes when they don't have bandwidth at a peering location, right? Human errors. So we have a solution called, that's why I said automation in everything we do, right? We have a solution called Network Insights that enables our customers to avoid mistakes on the peering router, right? So capital efficient routing, DDoS protection, automation to protect against routing loops and mistakes, especially when you are going distributed. And the fourth one is the cost of peering via steering. Okay, so cost of peering via steering. What do I mean by that? Because everything is segment routing enabled, you can actually select the right peering point if you have distributed peering now. Let's say instead of 3 peering locations, you have 64, a ring, big ring around the country. You can say, for this type of traffic, I want it to come from here. Netflix is going to come from these 4. YouTube, you are going to come from here. You could do all sorts of steering of traffic. And you could say, hey, this government traffic, this highly secure traffic, you go through these 2, and I'm not going to mix it with others. You can do those types of planning. Segment routing enables you to do that. Fair? All right, so that's our smart peering architecture. All right. Similarly, how many of you are here from the cable side, cable sector? All right, not many? Okay. Yeah. So, cable, obviously we see increasing deployment of remote PHY solution. So like John was mentioning here, when you see a lot of HFCs and other things showing up, how do you aggregate all that? You aggregate it through a network, like a IP network, right? We call it, the cable industry calls it SIN, okay? Not for SIN, SIN, CIN, SIN, all right? So this one is, I think I have only one message. We have a full architecture with automation for it, and do not just do it for aggregating cable. You can actually use it to offer backhaul to mobile providers, make some money out of it. That's a big, strong business case. You can use it for enterprise services. So build the SIN for cable aggregation, but use it for multiple revenue generating streams. So the same message that we gave when we talked about converged infrastructure. Okay, so we have a full architecture for it. One of the points I will highlight is you can also integrate DWDM into routing and save costs on optical networking. That era is coming. We have already seen massive deployments in certain parts of the world with that architecture and drops costs down by 50%. Fair? Okay. So I think I spoke through this. One other, remember converged infrastructure? So you brought cable through it. You can also bring TDM on the same network. So we have technology today that you could take, you could still keep your end last mile TDM connection. Service providers, customers pay more for a TDM connection. They do. So keep it. Keep charging your more money. Okay? But don't, after you brought them in to the first point, beyond that, it's expensive. The amount of real estate, power that all the TDM network takes, huge. We have technology now that your end last mile can be TDM, but everything else is IP Ethernet. And the economics of IP and Ethernet are way better. In fact, we have two major wins with Verizon and CenturyLink in terms of their TDM to IP migration. And just real estate savings pays for the whole project. Okay? So this is again backed by automation. So as I said, automation will be so we have a full offering here with automation. So these are the architectures that we are moving. So I think we had a full session on automation, so I'm not going to go through a lot here, but as I said, between our NSO framework, between our data gateway, and with our EP&M platform, we are able to help you from planning to design to implement to operate to optimize any of those architectures, whether it was peering, whether it was SYN, whether it was TDM to IP, whether it was IP plus optical, doesn't matter. We can automate it all, right? So that's the goal here. All right, so I made a statement earlier, which is that it's not just about the technology, it's also about the business model. So one of the things we have done is it's important to look at the network operating system as the platform, right? So when you imagine your network, don't just look at, I have edge router. Look at the entire network. And the entire network is running software. And if that software is fully automatable, it is fully trusted, it is simplified, it allows you to generate new services, then you could look at that software as an investment, as a strategic investment. And we enable you to do that commercially as well by looking at software from a flexible consumption point of view. You can buy at the network level. You don't have to buy it at a site level, this, that, and manage how many licenses I have. Don't worry about it. You can buy entire software at the network level and share licenses across. You pool the licenses across locations. So we made it easier for you to bet on a software investment. And then you can run hardware much faster because you need to, right? More efficient, less power, keep moving faster on hardware while you have paid for software on a longer term. So we have married the whole architecture approach with a business model approach, which we call as flexible consumption. And we have a lot of salespeople here. If you have more interest, absolutely talk to them, right? And you can also reach out to us. But this is gaining a lot of traction. We launched it about 3 quarters ago. And we have more than 150 customers who have purchased routing this way already. So it's very popular, and it reflects a strategic bet on software. Fair? So that's what I had for today in terms of network transformation. I hope you found it useful, and we'll be around if you need any discussions or anything. Reach out. Thank you.